Okay, in our last class we discussed about organo-zinc, okay, the preparation and their application in organic synthesis. So today we will discuss about organolithium compounds. Organolithium compounds. Organolithium means a carbon is bonded with the lithium. So lithium is a alkali earth metal, alkaline metal, alkali earth metal. Okay, sodium is the alkali metal, lithium is the uh, alkaline earth metal. Okay, so it belongs to the alkaline group. So the bond R lithium, the general structure of organolithium is called R lithium. R may be a aromatic compound, R may be a aliphatic compound. So overall, a carbon, if it is bonded with the lithium, then such compounds are called organolithium compounds. Okay. Maybe you can also look into the Mukherjee, page number 135, and Norman and Coxon, page number 197. Okay. So with respect to organolithium. So among the organometallic compounds, let's give an entry. Right. So among the organometallic compounds derived from alkali metals and alkaline earth metal. So first group periodic table is called alkali metal. Next one is alkaline earth metal. So next is D black elements, and the next is a non-metals. Okay. So organolithium compounds are most important. So because of its application in the organic synthesis. They possess a polar covalent carbon lithium bond. So they possess polar covalent carbon lithium bond. So that means polar nature means C minus L plus, but it is a covalent nature, but not the complete ionic. So general formula of R lithium. So in this, R may be a alkyl group. Alkyl means maybe a methyl, ethyl, propyl, butyl, means saturated carbon atoms. And the aryl group, aryl means aromatic containing compounds. So if it is a aryl, we can say that aryl lithium. If it is a alkyl, we can say that alkyl lithium. So organolithium compounds are more reactive than Grignard reagent. So what is Grignard reagent? RMgX. Okay. So that means in Grignard reaction, Grignard reagent, a carbon is bonded to a metal. So whereas in the organolithium, a carbon is bonded to a lithium. Okay, that is the difference. And one more difference is there. Okay, lithium size is less compared to the magnesium. Okay, that is a advantage. I will tell you where it is applicable, where the Grignard reagent fails to react with the hindered carbonyl carbon. In such cases, one can use organolithium. Since the size of lithium is less, so it will go and it will react with the reason organolithium are more reactive compared to the what is called as organomagnesium. So because of the size, that means uh, hindered carbonyl hindered carbonyl compounds. If a Grignard reagent is not able to enter and react, in such cases, organolithium will interact and form a carbon-carbon bond formation. So then, ionic character is around 60%. And of course, non-ionic ones are more reactive. So with this, I will go to the next slide. Next slide will give you the information about synthesis of organolithium compounds. How one can synthesize, prepare organolithium compounds. So next slide, I will go to the next slide. I will go to the next slide. I think I need to move to the next slide. One minute, it will move. I think it's not okay. The slide should move. You please be on the line. Okay, I think now it's moving. Right. Oh, let's give an entry. Okay. Right. So one more slide. Okay. So one slide is missing here. Right. Okay, it's regarding preparation. Uh, so, for example, an alkyl halide. Okay, so alkyl halide when it is react with organolithium. Okay, uh, it is possible to synthesize. Uh, uh, 1 minute. Yes. So this is the what is called as a direct metallation method of synthesis of organolithium, and two more methods is there. So alkyl halide when it is treated with lithium metal, it leads to the formation of organolithium. That is one method of synthesis. And one more method is there, that is called interchange. See, for example, methyl lithium, when it is treated with acidic proton containing organic compounds, that time there will be a formation of organolithium compound. Okay, it's about two methods. So one is metallation. So metallation means alkyl halide when it is treated with the lithium metal, it leads to the formation of organolithium compounds. That is one method. Another method is there. It's called interchange. So that means, for example, a methyl lithium when it is treated with alkyl halide, so it leads to the formation of alkyl lithium. Okay, that's called interchangeable interchange of alkyl halide with alkyl lithium. Okay, the two methods of preparation, and this will be the third method. So here a acidic proton containing organic compound is treated with organolithium to get another organolithium compound. So what will happen here? C6H5 lithium. So it's called phenyl lithium. So the anion, so here phenyl will be available as a anion. It's called arenium carbanion. So that means this can picks up a proton here, acidic proton. And this bond pair picks up a lithium. So that is how a organolithium is obtained. So then the physical properties, okay, these are either liquids or low melting solids. These are either liquids or low melting solid. So 1 minute, maybe what I will do, I will go back so that I will check the possibility of getting that preparation slide. Okay, so I will do a backward operation. One. Yes, see, look here, here it's there. So preparation of organolithium compounds. So from alkyl or aryl halide. So what is happen? Here I am taking a RX is an alkyl halide. ARX, okay, AR stands for aromatic one. Aryl halide. Alkyl halide or aryl halide, when it is treated with a metal. So here lithium is a metal. Okay, so it's a I think what you call, it's a brown colored compound, lithium metal. So what will happen? This metal react with the alkyl halide or aryl halide, leads to the formation of alkyl lithium or aryl lithium. Okay, with the liberation of LiX. Here X may be a halogen. Okay, so again halogen means maybe a chlorine, bromine or iodine. So and this reaction should be carried out in presence of argon atmosphere or nitrogen atmosphere, because these are hygroscopic in nature. What is hygroscopic in nature? Hygroscopic in nature means it will the compound will catch a moisture present in the atmosphere. So atmosphere will have a moisture. That moisture itself is enough to change the physical properties of the organolithium compounds. Even LiX means lithium halides also hygroscopic in nature. So that means they will catch the moisture present in the atmosphere. That is the That is the reason these reactions carried out under inert atmosphere. So inert means there will be a creation of nitrogen atmosphere. There will be a creation of argon atmosphere. Okay. So that is the thing you need to remember. Overall, the first method of synthesis of organolithium is the reaction of alkyl halide or aryl halide with lithium metal leads to a alkyl lithium or aryl lithium as the compounds. And the second method is halogen exchange. Halogen exchange with the metal exchange. Halogen metal exchange reaction. So what is happening here? You can observe that this is an alkyl halide. So this is an alkyl lithium. So what will happen? This lithium will form a bond with the R group of the alkyl halide, and this halide will form a bond with the R group of the lithium. It's called exchange. So that is how in this method also organolithium is are the products. So here I am taking an example. The name of this compound is called bromobenzene, and this is called butyl lithium. This is a it's an what is called as uh, it's a liquid. Butyl lithium is a liquid. I have used for my preparing certain compounds in the industry. So this should pass. Okay, you should not transfer it just like opening a lid and transfer to a measuring cylinder or something like that. So this requires a special technique. What is the technique means? You have to apply a pressure to the bottle. Okay. So and also there should be a connection, cannula. It's called connection. So that means one tube is passed, metallic tube is passed through this butyl lithium bottle and the reaction media. Okay, when you are applying a pressure, the liquid present in the bottle, it will push us from the lithium bottle to the reaction mixture. It's called butyl lithium. Why we have to do so? Because it's hygroscopic nature. That means if we are opening a bottle, it will catch as fire. If you are, if it is a catches fire means it's of no use, no? That is the reason. So butyl lithium can react with what is called as bromobenzene, giving rise to lithium phenyl lithium. Okay, the obtained phenyl lithium also should be stored in a close tight bottle, and there should be no moisture entry. So that means you should store under the atmosphere of nitrogen or argon. Argon is the better. Why? Because nitrogen also contain to some extent of moisture. That is the reason. So these are the two methods of preparation of organolithium. So with this, I will go to the third one. I think this you are aware that because I already discussed what is this organolithium when it is treated with acidic proton containing a substrate. So giving rise to organolithium. What is the name of this organolithium? Cyclopentanone. Okay, lithium cyclopentanone compound. It's a cyclopentane. Okay, cyclopentane lithium. So of course you know that this is a benzene. And here, so the storage of an organolithium compound requires hydrocarbon. Hydrocarbon may be a C6H14. C6H14 means it's called hexane. Okay, hexane, heptane. Okay, these solvents are required to store the organolithium. So why? Because this organolithium, if they are come in contact with the ether, they will react with the ether. So that is the reason organolithium compounds are stored in hydrocarbon solvents such as hexane, heptane, okay, pentane. Okay, that's all. Physical properties, these are either liquids or low melting solids. I have seen liquids. Butyl lithium is a liquid. Okay. Then readily soluble in non-polar hydrocarbon solvents. I think you are aware about the polar solvent and non-polar uh, hydrocarbon. So hexane is a non-polar hydrocarbon. Okay, hexane means C6H14. That is one example. Okay, and one more thing, there is a more demand for hexane because this will be the one of the constituent present in petrol. Okay, it's a low boiling solvent. More particularly, the boiling point of hexane may be somewhere around 50 degree. Okay, right. So with this, I will go to the next slide. So next slide is about the chemical properties. So because of the strong bond polarization of small size of lithium, alkyl lithium exits as a polymeric compound. So it's one point with respect to the organolithium. So, but here what I am talking, a reaction with the acidic substance. So acidic substance, it's also called as a deprotonation reaction. So what will happen here? Something like our, you know that Grignard reagents. So Grignard reagents are sensitive to the acidic or protons. Acidic protons are sensitive to carboxylic acid containing compounds. So what it will do? It will take the proton and liberate the hydrocarbon. So that means Grignard won't be there if there is a functional groups called as acidic proton containing functional groups. So similarly, similar to the Grignard reagent, organolithium also sensitive towards the acidic compounds. Acidic compounds in the sense a proton containing compounds. So carboxylic acid is a proton containing compound. Alcohol is a proton containing. What you call amine is also a proton containing one. So, if organolithium, when it is treated with a proton source, the proton source may be a carboxylic acid, maybe a phenol source, acidic compounds. So, what will happen? there will be a liberation. What is liberation? This R minus can react with this proton and there will be a liberation of hydrocarbon. So if we are taking a butyl lithium, so butane is the formed. So butane is a gas, it will go out. So that is the reason. So lithium, suppose if you are using acetic acid here, lithium acetate is the byproduct. Okay. So example, so one more here I am taking a example. So where there is a presence of acidic proton. Okay, this is the proton and this is acidic because of the nature of the substituents. And what will happen? A butyl lithium, so it's a base. Bu minus can abstract this proton. Butane is a gas, it will go out. And lithium can form a bond here. And this is a carbanion or a organo lithium compound. Of course, this is a reactive. This is a byproduct, it will go out. It's a gas, it will go out. So this is about reaction of organolithium with acidic substances. So I will take a few more examples. So in the next slide, so look here. So without, of course, name of this compound is called anisole, ANISOLE. Of course, it's called as a methoxybenzene, but trivial name of this compound is called anisole. So what will happen if this is treated with a butyl lithium? There will be a lithiation. Lithiation means addition of lithium. So where it will add ortho to the substituent. This is a substituent and this position is called ortho. So what it will do? Butane, Bu minus can abstract this proton. And BUH is a butane, it's a gas, it's going out. Then what is the forming? This bond pair picks up this lithium, form an anion here. So similarly, if there is a heteroatom, this is an heterocyclic compound. So heterocyclic compound, here also what will happen? You know that this proton. So this proton is captured by Bu minus. So butane is going out. Lithium will form a bond here. So this process is called lithiation. Lithiation means addition of lithium to the substrate. So in this, these are the two substrate. Okay, this is about what is called as lithiation. If there is a substituent, adjacent carbon lithiated. If it is a heterocyclic compound also, adjacent proton is replaced with the lithium, thereby it's called as a lithiation. So with this, I will go to the next slide. So next slide will give you the information about few more examples. Okay, this is called furan. Okay, Furan. Furan is a heterocyclic compound containing oxygen as the heteroatom. So what here what is happening? This butane can abstract this proton. BUH is going out, and there will be a new bond formation between this bonded pair and this lithium. Of course, we can call this as a lithiation. Lithiation of furan. Lithiation of what is the name of this compound? It's pyran. Pyran. Of course, there is a double bond. Uh, okay, and tetrahydro, we can say that because this position, this there is no double bond. Here to here, there is no double bond, right? Of course, here double bond is not possible because oxygen will have only a two valency. So what is the so without this double bond is called pyran, Pyran. Okay, since there is a double bond, what we can say that dehydro. So removal of H2, dehydropyran. So this dehydropyran, when it is treated with butyl lithium, so Bu minus can abstract this proton and forms an anion. So this is what is called as lithiation of dehydropyran. And this is one alkyne compound, a triple bond containing one. So this also when it is treated with butyl lithium, there will be an lithiation. So this proton is acidic nature because it's an acetylene proton. This proton is acidic. This can be captured and there will be a formation of lithium here. It's a lithiation. So with this, I will move to the next slide. Next slide will give you some addition reaction to the carbonyl carbon. So that means what happens when organolithium is treated with carbonyl carbon containing compounds. So right. So nucleophilic addition reaction. So this is a carbonyl compound. Of course, this is also a carbonyl compound. What is the difference between these two? This is a formaldehyde. Suppose R is not a, then it's called aldehyde. Formaldehyde means HCOH. Other than formaldehyde means maybe acetaldehyde or propanaldehyde, butanaldehyde, or benzaldehyde, whatever it is. So that means other than formaldehyde. So what it means? So this can react with butyl lithium. How it will react? Butyl lithium or organolithium. How it will react? A R minus will add to carbonyl carbon. So then this bond pair picks up the lithium. So the obtained compound is called alkoxide, more particularly lithium alkoxide. So lithium alkoxide means when R of lithium, R will add to this carbon, lithium will add to oxygen. That compound is called lithium alkoxide. Lithium alkoxide is an intermediate. This lithium alkoxide, when it is hydrolyzed, in the case of formaldehyde, it gives primary alcohol. In the case of other than formaldehyde, it gives secondary alcohol. So in the case of ketones, it will give you tertiary alcohol. This is about the what is the what happens when an organolithium is added to aldehyde, means formaldehyde, other than formaldehyde compounds, other aldehydes than formaldehyde and ketones. So you need to remember that. Anyway, I will explain in the next slide itself. So look here, I am taking here. This is a organolithium compound. So this organolithium, when it is formaldehyde, so what will happen? There will be a new bond formation with this R group and this carbonyl carbon, and there will be a new bond formation between this oxygen and this lithium. So this is called lithium alkoxide. This lithium alkoxide is hydrolyzed. Hydrolyzed means the bond between the oxygen and lithium picks up a proton from here. So that means the obtained compound is a primary alcohol. So that means a on reaction with organolithium gives primary alcohol. So similarly, a aldehyde. So aldehyde in the sense other than formaldehyde, when it is react with an organolithium, it gives secondary alcohol. Similarly, a ketone, when it is react with organolithium, it gives a tertiary alcohol. Okay, this is about what is called as what happens when organolithium reacts with different kinds of aldehydes. Aldehydes may be a primary formaldehyde or may be a acetaldehyde other than formaldehyde or may be a ketones. Okay, this is about what is called as reaction of organolithium with carbonyl compounds. So with this, I will go to the next slide. So next slide. So look here. Here I am taking a alpha beta unsaturated ketone. This is called alpha beta unsaturated ketone. So what is the name of this compound? This group is called vinyl group and this group is called methyl group. So vinyl methyl ketone. Vinyl methyl ketone is a trivial name or common name, but not the IUPAC name. Okay. So then what is the IUPAC name? So then you have to number and then you have to say that it's a butene. Okay. More particularly, 1 butene, 2 one. Butenone is the IUPAC nomenclature. So when butenone is treated with methyl lithium, so again methyl lithium. So look here, what is happening? I said that it's an addition reaction, and you know that 1,2 addition and 1,4 addition. So this methyl lithium does not attack the fourth position; it only attacks the second position, 1,2 addition. That is the speciality about methyl lithium. So what will form? This CH3 minus will form a bond with this carbonyl carbon, and this bond pair picks up a lithium and forming a compound called what is called as a tertiary alcohol. Tertiary alcohol is possible only when two equivalents of methyl lithium react with ketone. Okay. Similarly, here I am taking. So you know that this is a tertiary butyl group. This also a tertiary butyl group. Then what is the name of this compound? Ditertiary butyl ketone. Ditertiary butyl ketone is a hindered ketone. So in this case, if we are using a Grignard reagent, there won't be no reaction. No reaction. So that means a ditertiary butyl ketone does not react with the Grignard reagent. So because of the steric hindrance. So whereas the butyl lithium, lithium is a small in size. It can reach here. Okay, it can reach here. Okay, so that is the reason butyl lithium is more reactive or better reactive compared to the Grignard reagent in the case of hindered ketones. Okay, that's what you have to mention. So what will happen? A tertiary butyl anion react with this carbonyl carbon, and this will picks up a proton that means a lithium. So that on hydrolysis gives alcohol. This is a tertiary alcohol. This is about what is called as what happens when organolithium is treated with alpha beta unsaturated ketone and also hindered ketone. So with this, I will go to the next slide. Okay, I will go to the next slide. Look here. So addition reaction with hemines. So what are hemines? C double bond N containing compounds are called hemines. So what are nitriles? Nitriles means CN containing compounds. Isonitrile. Isonitrile means NC functional group containing compounds are called isonitrile. This may be a little important because imine will give you one kind of product, a nitrile will give you another kind of product, and isonitrile will give you another kind of product. So what is here I am writing. So look here. C6H5 means benzene group. C double bond N C6H5. So that means it's also called as a skip base. That imine. Why it is imine? Because C double bond N functional group is there. So what will happen here? 3 minus. In this CH3 form of anion that will attack a carbonyl carbon. This is not a carbonyl carbon. This is a imine carbon. So when this forming a new bond with this imine carbon, this bond pair, okay, so picks up this lithium. Of course, that lithium is replaced with proton when it is treated with H3O+. H3O+ is a proton source, and H3O+ is called hydronium ion. So that is how a product is obtained. So you can observe that here a methyl is from the Grignard means organolithium, and proton is from the solvent source, proton source. And the second example, look here. Second example is a pyridine. I think you are aware about the this structure. This is a pyridine. Of course, this pyridine itself is acts as a imine. Why it is act as a imine? Because it contains C double bond N. C double bond N is called imine. Since it acts as a imine, it will react with butyl lithium. How it will react? The Bu minus, okay, Bu minus can attack this carbon. Why it is attacking this carbon? Because this lone pair or this bond pair will form a bond with lithium. So this intermediate is obtained like this. And afterwards, this bond pair can come over here. This Li minus and this H plus going out as a byproduct and forming a butyl pyridine. So that means there is a reaction between butyl lithium and pyridine. Suppose a substrate contain pyridine means if we are using a butyl lithium as a reagent, there is a possibility of forming butyl pyridine as the product. So this is about what are the products obtained when an imine is treated with butyl lithium or methyl lithium. So in the next slide, I will explain about what happens when organolithium is treated with nitriles. So look here, this is a nitrile. C triple bond N is called nitrile. So what will happen? This anion will attack this carbonyl carbon and this will picks up a proton. This imine on hydrolysis, NH is replaced by O. So that is the reason the obtained compound is called phenyl butyl ketone. Phenyl butyl ketone is a IUPAC name. What you call trivial name. It's not a IUPAC name. Then if we are looking into the mechanism, so this anion part is attacking here. This bond pair picks up a lithium. That is how an intermediate is obtained. So this on hydrolysis means this bond pair picks up a proton forming an imine. So to this imine, the water or hydronium ion so can attack this carbon. This can picks up a proton. So that is how this NH will go out as a NH3 and forming a ketone, phenyl butyl ketone is obtained. So what it means? Nitrile on reaction with butyl lithium gives nitriles. So with this, I will go to the next slide. Next slide will give you the information about what happens when organolithium react with isonitrile. Isonitrile means I will look. So go to the next slide. Look here. Isonitrile means NC. NC containing functional group is called isonitrile. So isonitrile when it is treated with organolithium, and here in the second step I am using electrophile. So electrophile may be a chlorine or bromine or NO plus. NO plus means nitrosyl cation. Okay. So there is a product formation like this. If you want to know how this product is obtained, you can look into the mechanism. So in this case, R minus add to the same carbon atom, and at the same time this anion present on the carbon also react with the lithium. So there will be a formation of intermediate like this. So this intermediate react with an electrophile. Electrophile may be an alkyl halide or aryl halide, or may be a electrophile such as Cl plus, Br plus, NO plus, NO2 plus, okay, so, SO3H plus, something like that. So this is the product. This is about what is called as organolithium. So today we discussed about organolithium preparations, okay, and their applications. More particularly, what happens, what are the products formed when it is treated with carbonyl compound, when it is treated with heteroatoms, when it is treated with imines, when it is treated with nitrile, when it is treated with isonitriles. Okay, this is about today's class. So if you have any doubt, you can ask. Okay, if there are no doubt, means you can log out for the session. Okay.